Hi everyone, this was our Venn diagram from back in section 0.1 for sets of numbers. So far, we've been keeping it real. But now we're going to extend to the broader set of complex numbers, C, where we're going to throw in the imaginary numbers, such as I. Later on, we're going to talk about the complex zeros of a polynomial function, which could be real or imaginary. Section 2.4 is on complex numbers in general. Now, -1 has two square roots, called I and -I. I is the principal square root of -1, and we call I the imaginary unit. I squared is therefore -1 itself, and that's something that you use a lot. Now, when you simplify radicals, such as these, you need to make sure that the new radicand becomes non-negative. So for example, the principal square root of -15 is written as I root 15. If you want, you could write this as root 15 times I, but what's the danger? A lot of students extend the radical too far and put it over the I, which would be wrong. You're not supposed to do that. So if you're afraid of doing something like that, then it might be better for you to just put the I out in front. Root -16 is I times root 16, or just 4I. Root -18 is I times root 18. And then old school, root 18, because 9 divides 18, and root 9 is 3, basically the 9 comes out of the 18 as a 3, and the 2 stays behind. Again, 18 is 9 times 2. The 9 comes out as a 3. We have 3 root 2. That's I times 3 root 2, or 3I times root 2. Again, it might be safer to put the radical at the right end. Standard form for a complex number. Something like 2 plus 3I is an imaginary number written in standard form. A is the real part, which is 2 here. B, or BI, is the imaginary part, which is 3 or 3I over here. Standard form is A plus BI, where A and B are real numbers, and one or both could be 0. Again, C is the set of all complex numbers, and every real number is a complex number. R is a subset of C. Every real number is also a complex number. So even numbers like 7 or 0 are also complex numbers. So all of these are complex numbers. 2 is an integer. In fact, it's a real number. That's also a complex number. 3i over here is a pure imaginary number because the real part is 0, and it's not 0 itself. 2 plus 3i is another imaginary number. Over here. All right. Now, the real number line represents the set of real numbers. If you have two distinct real numbers, like -1 and pi, we know that one has to be greater, one has to be lesser. But what if you have two imaginary numbers, like 2 plus 7i versus 4 plus 5i, which is greater, which is lesser? It's kind of hard to say. There's no such linear ordering like for the real numbers. Instead of a real number line, we represent the set of complex numbers using the complex plane. So if we want to plot a number like 3 minus 4i, we're basically plotting the ordered pair 3 comma -4 in the complex plane, a comma b, where a is the real part, b is the imaginary part. So 3 is on the real axis, -4 is on the imaginary axis. These take the place of the x and y axes. And here's 3 minus 4i. Every point in here corresponds to a complex number, including 0 over here. Next up, we're going to discuss powers of I and how to simplify them.